So I hope you liked Boyle's Law because we got 2 more gas laws coming your way. Watch out! Alright, so we got Charles and Gay-Lussac's law. So I'm looking at this figure. It says Charles' law states that volume, I know that's my boy V, is directly proportional to the Kelvin absolute temperature when pressure is constant. Because remember, Kelvin is the only temperature that has 0 is actually the lowest temperature possible. That's why it's absolute. So pressure is constant. That's interesting. Directly, that's like the opposite of indirectly. So that probably means like one goes up, the other goes up, because indirectly is opposite, remember? Okay, so, oh, yeah, I mean, look at the graph. As temperature goes this way, volume goes up. So if temperature is right here, and then you double temperature, boop, the volume is doubled. But that says only when pressure is constant. Let's read what this says. The next significant advance in the study of gases after Boyle's law, my boy, came in the early 1800s in France. You have to say it like that, France. Hot air balloons were extremely popular at the time, and scientists were eager to improve the performance of the balloons. So this is interesting history, but it doesn't really tell me anything about science, and since I'm reading for science, I haven't underlined anything, since nothing's really that important. I do think it's funny that hot air balloons, they're like souping up their hot air balloons, like hot rods. Okay. 2 prominent French scientists, Jacques Charles and Joseph-Louis Gay-Lussac, made detailed measurements on how the volume of a gas was affected by the temperature of the gas when the pressure was constant. So volume and temperature. Given the interest in hot air balloons at the time, it's easy to understand why these men should be interested in the temperature-volume relationship. Yeah, that's what I just identified. They found that there was a proportional relationship. Okay, proportional, that's what it says up there too. As long as the pressure didn't change. So pressure must be constant. As one variable went up, so did the other. The equation for Charles' law is, I don't know where it is, but this is what it is. P1, well, not, pressure's constant, sorry. V1 over T1 equals V2 over T2. Must have not got copied for some reason. So let's go on and read about Gay-Lussac's law. So now this says Gay-Lussac's law can be derived, I know that means found or created, from Charles and Boyle's law. The law tells us that if all else is held constant, temperature and pressure will be proportional. Okay, well temperature and well, what else is there? Volume. So volume equals constant for Gay-Lussac's law. It's interesting. Each of the 3 has held one of the other variables constant. Okay, so proportional. So again, that means one goes up, the other goes up, I guess, because that was the same. Which, the graph has the same shape as Charles' law. It's just here, this is pressure instead of volume now. Okay, what's it say? High temperatures cause gas particles to move faster, collide more, and increase pressure. Well, yeah, I mean, if it's going like then it's going to collide with the surface more, and the pressure is going to increase. This is why it's dangerous to heat pressurized cans. Dangerous, but fun. Don't do it at home. Do it at your friend's home. And actually, don't do it at all. Okay, I just got to say it on record. Don't do it at all. Okay, so an increase in temperature can cause so much pressure to build up that the can explodes, right? Because the particles are moving faster and faster, and then they're hitting the sides of the wall faster, and then there's more pressure, and so it can burst the can. Gay-Lussac's law can be expressed as P1 over T1 equals P2 over T2. This is interesting. This is the same setup as Charles' law, except Charles' law has V instead of P. Interesting. So both Gay-Lussac and Charles have proportional relationships. As temperature goes up, pressure goes up if volume's constant, and volume goes up if temperature's constant. Let's record those as key points. So we're going to have Charles. We have V and T are proportional if P is constant, and then Gay-Lussac's, we have P and T are proportional if V is constant. Very interesting. Oh, I didn't change it to blue. That's so sad. Oh well, it's not that big a deal, I guess. So those are my key points. Fun stuff. See you in class.